Welcome to the Orchestrate All the Things podcast. I'm George Anatiotis and we'll be connecting the dots together. Is incremental change a bad thing? The answer, as with most things in life, is it depends. In the world of technology specifically, the balance between innovation and tried and true concepts and solutions seems to have tipped in favor of the former. Or at least that's the impression reading the headlines gives. Good thing there's more to life than headlines. The ScyllaDB team is one of those who work with their garage doors up and are not necessarily after making headlines. They believe that incremental change is nothing to shun if it leads to steady progress. Compared to the release of ScyllaDB 5.0 in Scylla Summit 2022, what ScyllaDB Summit 2023 brought could be labeled incremental change. But this is just the tip of the iceberg, as there's more than meets the eye here. I caught up with ScyllaDB CEO and co-founder Dor Laor to discuss what kept the team busy in 2022, how people are using ScyllaDB, as well as trends and trade-offs in the world of high-performance compute and storage. I hope you will enjoy the podcast. If you like my work, you can follow Link Data Orchestration on Twitter, LinkedIn, and Facebook.
So hello, everybody. I'm Dor. I'm the CEO of ScyllaDB, also a co-founder. I'm an engineer in my roots. I was involved in lots of different projects in the past, from terabit router to creation of the KVM hypervisor, together with my other co-founder, Avi, from zero to the point where it was enterprise solution and got propagated to the different cloud providers. And also with Scylla, we initially created an operating system from scratch in open source that exists today, but we pivoted to the database space. And in the past 8 years, we've been building the ScyllaDB database.
Great, thank you. So with that said, I should also add a little bit of context from my side that, well, it's not the first time we connect, actually. We go back a few years. I believe the first time was actually in 2017, if I'm not mistaken. But I'm pretty certain about when the last time was. It was precisely 1 year ago. And at the time, there were a few things going on. So first, same as now, you just had your main event, the ScyllaDB Summit, and you had also released a new version back then. So back then it was version 5.0 of ScyllaDB. And I thought a good way to start the conversation today and see what's going on around not just ScyllaDB, but in general, would be to pick up on the main themes that sort of emerged from last year's conversation. So the main themes were cloud and real-time data. And one of the things that you mentioned last year was how much growth you were seeing around ScyllaDB's cloud offering. And I just thought I would ask by asking you, so has that growth been sustained throughout the year, so from 2022 to 2023 today?
Yeah, so the answer is simple. It's absolutely yes. We've been growing over 100% year over year in Scylla Cloud. That's our database as a service. So we see strong growth, and it will continue to grow. That product, the service, exceeded 50% of our revenue. So today, a majority of our paid subscriptions are coming from the database as a service component. And we'll see this theme continue. In general, everybody needs to have the core database, but the service is the easiest way to consume it, also the safest. And this theme is very strong with Scylla, but it's also very strong with the entire industry across the board with other databases, and also sometimes beyond databases with other type of infrastructure. It makes lots of sense.
Yeah, indeed. And the one thing that sort of stood out for me about your cloud offering from last year was the fact that well, obviously you support AWS and Google Cloud, but for some reason, at least last year, there was no support for Azure, and I'm wondering if that has changed.
That's correct, and that hasn't changed. We do support Azure in our core database, both the open source offering and the enterprise offering. We actually developed now a relatively simple mechanism to support Azure with the Azure Marketplace, uh, primarily in order to allow gaming companies who use the Epic Games stack that Scylla is part of it to consume Scylla simply on Azure. Um, but didn't have the time to add the Scylla Cloud DBAS to Azure. Not that there's lack of will or demand. Primarily, we just can't do it all. And we've done many improvements to our Scylla Cloud. We'll probably talk about many of them, but the primary one is the switch to serverless. So
Mhm.
this is our main focus, to switch to serverless. Probably later it'll be easier to add Azure as a target.
Okay, I see. Indeed, yeah, you did mention serverless, and that's also something I picked up, well, basically from your talk in the recent event yet, that you just had. It was very prominently featured there. So indeed, we will revisit it and talk about it in more detail. But since we're still in the introduction, let's move on to the other main theme from last year. So real-time data. And I know that ScyllaDB has, I think, fairly recently, probably also a little earlier from last year, you have recently added support for CDC, so change data capture. And a big part of what we talked about last year were basically use cases that we're using that. So I'm wondering if you're seeing that momentum also maintaining or maybe picking up speed as well.
Yep. Users and customers like our CDC solution. I really take lots of pride in it, although I didn't invent the way it's implemented. But it's really nice that all of the CDC events, all of the changes events, go to another table, and there users can consume the other table as a regular table. So it's pretty much a very neat interface, and obviously it's connected to other connectors as Kafka if there's a need. So it's trivial to support it, to consume it either through Kafka or through the library that we allow just to access it as a regular table. And the usage is picking up. And also, we see sometimes that there are cases. Usually, these days are more of an exceptions, but we see the number of use cases that increase. That Scylla isn't just used as a database, but also sometimes used as an alternative to Kafka too. So it's not that it's a replacement for Kafka, but if you have a database plus Kafka stack, there are cases that instead of queuing stuff in Kafka and pushing them to the database, you can just also do the queuing within the database itself. A year ago, Palo Alto presented their case where they eliminated Kafka. Not because Kafka is bad, it's great, but just to reduce the infrastructure and have
Mhm.
less moving parts. And just in the summit just now, we had Numberly, one of our customers, who also wanted to eliminate. They wanted to eliminate Redis, which they have, and to eliminate Kafka altogether. Yeah, so they've done it, and now they have a way easier stack.
Mhm. Yeah, indeed. I mean, you're right. Modern data stacks are getting more and more complicated with more and more layers and more, well, vendors in the mix. So I'm pretty certain that if users have the chance to simplify it, they will choose to go for it. I do remember the Palo Alto use case from last year. I also saw Numberly from this year's event, and that's actually a good segue to talk about well, what was featured in this year's event besides Numberly, which you just talked about. Just browsing through all the presentations, there were again a couple of main themes that stood out for me. And the first would be migration. You had a number of use cases in which people from different organizations, such as Discord or ShareChat or Confluent, even presented use cases in which they migrated from other solutions to ScyllaDB. And so I'm guessing that this is something that probably happens a lot in your users. So I was wondering if you'd like to just share a few words about, well, how do people approach it in general? And then maybe even if you wanted to comment specifically on those use cases that were presented this year.
Mhm. Um, yeah, so usually, as you said, and cheers for following the summit and all of the content. Um, Usually, since we're a relatively very scalable solution, sometimes users start with another database because they don't have the scale, and over time they hit a wall and they need to switch to a better database that can scale like us, and then it's time to migrate. So we see a lot of migrations. Um, Migrations from we support two compatible APIs, Cassandra API and the DynamoDB API. Some of them, by the way, sometimes CDC can come into play, or more for
Hmm.
Dynamo streams, and it can help migrations. And we have several migration tools. One of them is a project called Spark Migrator, where it scans the source database and it writes to a target database. And if that source database supports change data capture, we also capture the changes. Otherwise, you need to do double writes, which is another possibility. The scores specifically uh, wanted to, they rewrote the migrator in Rust and got better performance. Although uh, there's not necessarily that much of a performance concern with the Spark migrator, since it's scalable, so you could just run several engines. ShareChat also, they just run dozens of services, so it's not just migration of one or two; it's migration of plenty. So that's sometimes can get complicated, and sometimes there is an existing data structure called counters, which is more challenging to migrate, and it's not idempotent, so it's a little bit more challenging. But we're doing it. We used to do that. Many other customers, by the way, choose to rewrite their stack without keeping the API compatibility. We see that too. Many times it's an opportunity to change a programming language. So if someone was used to do JavaScript or PHP in the past, now it's time to move to a newer language like Go or Rust.
Hmm. And the other theme that was sort of emergent, let's say, by just browsing through the presentations in ScyllaDB 2023 was high performance. I mean, of course, that's sort of not new, really, since this has been kind of the epicenter of ScyllaDB's value offering from the beginning. It just occurred to me that I saw a number of presentations that were focused specifically on that. So getting the most out of ScyllaDB. For example, there was Epic Games, there was Optimizely, and Strava. Those were the ones that stood out for me. And you also mentioned Epic Games specifically previously when you were talking about how you are part of their stack. That was something I missed. So I wonder if you wanted to clarify how exactly do you work then with Epic Games?
So I'm really excited with the Epic game case because it's part of the Unreal Engine and all of the graphic engines for like many of us grew on the Unreal Engine. So it's super gratifying to see something like this. Also Strava, since I'm a
Hmm.
mountain bike rider, so it's really nice to see this usage translate to day-to-day life. Um, the Epic Game usage is such that they basically store Scylla, use Scylla as a blob store, as a fast distributed storage. They already have a storage layer that they store in S3. And S3 is slow, is fantastic, but slow. Primarily, the latency is a
Hmm.
problem. So they use Scylla as a cache over S3, and they store both metadata and also smaller objects, not gigantic ones, but also smaller objects in the size of megabytes.
Hmm.
Uh, and they build that stack for many of their gamers. It's not just for the some of the games that they develop, but also it's kind of a game engine and game library. So hundreds of organizations uh, can use that stack, and they can either use open source or enterprise or as a service with that use case.
Okay. Okay, I see. And you also mentioned earlier, when again you were talking about Azure, that this is the infrastructure that Epic Games is using, and therefore they're using ScyllaDB on Azure, right?
Correct. So Epic Games and Azure have partnerships around providing the entire Epic Game Unreal stack, which includes plenty of other components. And they wanted to make it available and easy to consume on Azure. And Scylla is one of the components. So we're adding Scylla to the marketplace, so it will be pretty trivial to consume Scylla on Azure together with the rest of the Epic Game components.
Hmm. You also mentioned something else just a little bit earlier, that some of these clients, some of these use cases use the database as a service version, and some others also use the open source version. So, out of those that we mentioned so far, so Discord and ShareChat and Epic Games, which version do they use?
So the Discord and ShareChat are using the enterprise version,
Hmm.
and Epic Games or the different usages that Epic Games provide use a mix. Epic
Okay.
Games in general, they try strive to use since they kind of they make a choice of technology, and later on, and sometimes they're not the it's more of a reference architecture in the recommended stack,
Hmm.
then everybody else get to implement it. So they're trying to use the least common denominator, and
Okay.
then there are hundreds and thousands of gaming vendors, and each of them need to select their own preferred way of consumption. We see the same case that there's sometimes there are cases where Scylla is selected for um, cryptocurrency and digital currency products, but uh, by a committee of the technologists, and they use open source, and then everybody who want to implement that
Hmm.
may choose to use the enterprise version.
Okay, I see. Um, Right, so I didn't actually realize that was the way ScyllaDB was used in the Epic Games context, and actually I didn't understand how exactly their stack works. I had the impression that, well, it was a stack that was used internally by them, but actually, based on what you just said, it sounds that's not actually the case. I mean, yes, they do have an internal stack that they use, but they also sort of recommend, let's say, this stack is adopted by their network, um, the people, the companies that they work with that implement their games, or how does that work exactly for them?
And so it's not that I know the overall details, but
Hmm.
like in the past, where this Unreal was basically a library engine, and in the past, like my more for childhood games and all that, like you just used to download the game, and
Hmm.
you got all of the binaries, and then you just run it on a single computer, and
Yeah.
that was that. So and uh, other games could just buy or license the Unreal Engine.
Hmm.
And this was the way of consumption. And today, in our era, everything is more complex, and there is cloud, and everything is distributed. So it's the story continues. Now the way Scylla is part of the stack, it's not for the actual game. It's for more of the game manufacturers to create the game, because there's a lot of graphical objects that are really heavyweight, and the game manufacturers are large team distributed across multiple geos, and they need to collaborate and always to download all of these big heavyweight in access, and to enumerate all of these graphical resources. And this is why they need to store it on S3, and also to have a distributed cache, which Scylla provides the functionality there to accelerate that.
Hmm.
So everybody who wants to develop a, a game using the overall distributed Unreal infrastructure, including tools to develop the game, will use it.
Okay, okay, I see. So yeah, that's another thing that stood out for me in that description that you shared was the fact that, well, ScyllaDB is used as a cache. I mean, traditionally, historically, let's say, I think it was mostly solutions like Redis, for example. So very, very lightweight, just key value stores, basically. It's the first time, at least for me, that I hear about such a use case in which ScyllaDB is used as a cache, not as the main database, let's say, but as a cache. Is that something that you see happening elsewhere as well?
Um, yes, the quick answer is yes, but now there are different types of ways you can think about as a source of truth and a cache. Like traditionally, Redis is a cache in front of another database. So in this case, it's less relevant because Scylla itself doesn't need to be doesn't need a cache, and so most of the time it's not the right use case so for Scylla. But there are variety of ways that you can think about the data and caching. In this particular case, it's caching in front of S3, and it's basically a fast distributed storage. It happens to be a cache because they want to keep like S3 is obviously larger, and you just need to save the most commonly used object in Scylla because it's S3 is cheaper. But it's quite common pattern. There was another presentation at the summit that had another S3 caching type of layer of really interesting one, and that caches tens of thousands of Parquet files that are stored on S3, and ScyllaDB caches the metadata for these tens of thousands of files. And, but it can sometimes be we have customers who keep the data in variety of sources, not necessarily one place, and they store data on Scylla for very fast access. Now it's possible to regenerate the data, but it's expensive, and also to access it the access needs to be super fast. And
Okay, okay, I see. Well, speaking of events, by the way, there's something else I learned about ScyllaDB just fairly recently. So besides the main event that you have, so the summit, it seems that you're organizing another one, which is called the P99 Conf, and I was wondering if you'd like to just share a few words about it. So what's the motivation basically behind doing that, and what is this conference about? And a little bit, obviously, you participate in that as well. So, yeah, who is it for, and what's the main idea?
Absolutely. It's something that I'm very excited about. So, in general, we're a database vendor, but we also were involved in different other uh, development in before the Linux kernel, our own OS that we created, OSV, a KVM hypervisor, and also sometimes, let's say, at the Scylla Summit, many people would like to listen to how the database is supposed to use and what are the features, but it's not necessarily the best venue to provide the details of how we build our technology because it's too down in the weeds. So we thought of coming up with a separate event, which is not unique to Scylla, and it's more intended for developers to it's an event by developers for developers in order to expand the knowledge and to uh, eh, focus around performance and real time. So, and it's not necessarily a Scylla event or not a database event. So, we encourage people to present databases, including competitors, operating systems development, programming languages, special libraries. We have a mixture of all of these things. And the idea is not about products, but the emphasis is about technology. It's about code. It's about improving and optimizing infrastructure.
Hmm. Okay. I should probably also mention here that, well, it's probably very, very obvious to you, but maybe it's not necessarily equally obvious to everyone that the P99 refers to the 99th percentile. So it's a direct reference to availability, basically, and, well, having high availability and all that. And I think one of the presentations that caught my attention in that event was basically making the point that, well, maybe, the 99.9999 availability is not always what you need, because it's it's a lot of effort to reach that, and, well, maybe sometimes the trade-off is not worth it.
Mhm. Yeah. So actually, originally the P99 is supposed to be P99 latency, but you're 100% correct that it's also applicable to availability. And actually, I covered this in my recent talk there. Uh, so it's about availability. It's about predictability of the performance. It's about multiple things, and it's important. While it's all exciting and important, it's not necessarily important to everyone. It's expensive to have a near perfect system, and not everybody needs a near perfect system all the time. So there is also interesting talk there by Gil Tene, which who talks a lot about latency, and he mainly says, okay, don't necessarily look at the P99 alone. You need to actually think about the service level that your application needs. This is the number one OKR number that you need to track. Now, if in order to reach your targets, you need a great P99, then go ahead, measure it. But it's important to not to switch the means with the actual goal.
Hmm. Yeah, indeed. Another presentation and another presenter that you had, which I think was of note, was Brian Cantrell. And again, for people who may not know who he is, well, let's say he's somewhat of a celebrity in software engineering. Used to work at Sun Microsystems, and then Oracle, and then VP of engineering at Zoyant, and, well, a person that many people in this trade, let's say, know and are keen to listen to. And one of the points that he made in his talk was about using Rust. And well, he was very enthusiastic about it. He basically said something along the lines of, "Well, I've been using C throughout my career because it's the most performant one and the one I'm most comfortable using. But now that I've discovered Rust, it seems to be everything that C had, and then actually a little even better because it's easier to use, basically." And I noticed that ScyllaDB is also embracing Rust as well as Go, as well as WebAssembly. It seems they're used, as far as I could tell, at least, mostly for the moment in creating drivers for ScyllaDB. And I'm wondering if you'd also like to share a little bit of, the motivation. Let's say what's happening there. It seems there's a little bit of internal R&D going on, and using those languages is part of that.
Mhm. Yeah, we're fortunate to have fantastic people present at the P99, and it's also for the audience. It's free and it's online, and it's also recorded, and you can just go and watch all of the videos for free that were presented. So it's never late, including Brian's talk.
Mm,
And yeah, Rust is taking over the world, and it's fantastic language. We at Scylla started the ScyllaDB core in C++ before Rust was invented, and for us, C++ was a big improvement over C. Also, our the OS that we created was also based on C++, which is a big improvement if you used to code in C in the Linux kernel. So C++ is way better, but Rust has advantages. It takes care primarily it takes care for object lifetime and memory allocation for your behalf, and that's a significant advantage. And nowadays there's really lively community around Rust, so things are moving faster. And this is one of the reasons that there was no point in rewriting Scilla in Rust because uh, our C++ core is extremely sophisticated. Um, and it's really good today. But in the driver case, we developed a Rust driver, which has fantastic performance, and we like it's supports all of the fast use cases that people use Rust. And at the summit, you can observe that Discord moved from Go to Rust, and Numberly moved from Python to Rust. So many of our users are moving to Rust. Some of them with take our sharper core architecture and implement it on the client side too, like Numberly. And what now that we have a Rust driver, uh, we like not to maintain the Scilla C++ driver, and instead we created a C++ wrapper over the Rust driver. So it allows us to invest in a single driver. There was a network hit. It allows us to invest in a single driver uh, for the majority of the time, and then just wrap some layers for other programming languages, not for all of the programming languages. Like for JVMs, we'll continue to develop the JVM.
mhm.
And
Okay, I see. So, yeah, indeed. I was wondering because a key part again of your value proposition was basically originally re-implementing Cassandra's API in C++ as opposed to using Java, which is the language that it was originally written in, and that gave you, well, that and your C star library gave you boost in performance. So just out of curiosity, if you were to start today, do you think you would maybe start doing that in Rust instead of C++? I mean, I know you just said that it doesn't make sense for you to port it now because you've already invested a lot in doing that, and you have over time fine-tuned your code base and everything. But theoretically speaking, if you were to start today, do you think start you would maybe start doing that in Rust?
most likely, yes. Avi, our CTO, is the main figure who will to lead such a choice, but probably yes. Now we won't port Scilla C++. We're using cutting edge C++. So we're using C++20, and now we're excited about C++23, and it's very different than the C++ that I learned in university. But still, it's not exactly like Rust. I believe that C++ will continue to evolve and maybe provide tracking of memory allocation itself, maybe. But one thing that we talked about internally is to add Rust binding to Scilla core itself in order to write some components in Rust and not C++. So for example, some of the control path, for example, it's easier and safer to write in Rust, and it may not necessarily require lots of re-engineering. So it can provide value. It's something that we like to do. It's similarly to the work that was contributed to the Linux kernel to add Rust to it as well.
Okay, so now we've eventually gotten into well, talking about R&D stuff, I guess, and I noticed that you happen to have a new VP of R&D, and you also mentioned earlier in the conversation about serverless, which is an area that you're actively developing. So then let's bring that all together. So what's your main R&D directions then for the coming period?
Nowadays, we have several big directions, large efforts that we do, and the company could continue to scale. So we have a larger and larger team. In general, the team is divided between the core database and the as a service component. Plus, we have a large team to handle Kubernetes, which is part of the serverless offering. But some teams, there is a lot of cross-team work projects because we're working on several projects. So serverless, it's also a cross-team project because it contains lots of different sub-projects. That's one major activity. Another project is our strong consistency based on Raft. It's a project that began 2 years ago.
Mm-hmm.
It's already part of the ScyllaDB offering, but now the release that we're about to ship, 5.2, contains a strong consistency for some of the metadata operations by default. So we'll offer strong consistency for Scilla metadata, which will make it easier to maintain and also make it more elastic. So we'll be able to scale faster. This is a area where it's pretty important for database as a service and also serverless. So that's based on Raft, and we already have in experimental mode a mode where we're not eventually consistent, but we're strongly consistent based on Raft, and that will replace our previous lightweight transaction ability. Now, beyond this, we have another big activity around the object store. Once you move to the cloud, exactly like all of the other users who adopt object store in F3 and try to accelerate using Scilla, we also like to use S3 because it's a sea of storage, of extremely cheap storage on one hand, but on the other hand, it's also slow. But if you can marry the two, then you manage to break the relationship between compute and storage, and that gives you lots of benefits from extreme flexibility to lower TCO. And this is a main project we're working on too these days.
Okay, yeah, indeed, that sounds quite major, I would say. So if you manage indeed to leverage S3 as your storage, I'm guessing that it won't be your exclusive storage because, as you very correctly pointed out, S3 is abundant, but it's also quite slow. So I'm imagining that you will probably want to combine it with some other form of storage, I don't know, NVMe or whatever else. But if you manage to get it, then I think that will be quite well received.
Exactly, that's the idea. We'll store data on S3, but we'll cache and hold multiple objects. Some of them will be in a distributed, consistent ScyllaDB table, uh, just to access our own metadata, exactly like some of our users. And some of it will be in the form of caches, but not cache that you place in RAM, but cache that you place in local NVMe.
Hmm. Yeah, I see. By the way, you also mentioned something else earlier about when some of these new features are going to be released, and you said that they're going to be included in the upcoming ScyllaDB version 5.2. So just to clarify, there's two versions of ScyllaDB, right? So there's the open source version. I'm guessing that's the one that you're referring to, and
Mhm.
there's the enterprise version as well. What may be a bit disorienting is that the numbering is not exactly the same. So you just released a major version, so version 5.0 last year, and now you're following up. The current one is, I believe, 5.1, and you're going to be releasing 5.2 soon. While for the enterprise version, the numbering is different. So I believe there it follows a different pattern. So it's characterized by the year of the release, and then you have a point one or point two or something. Or what exactly is the relationship between those two, and how do features move from one to the other?
Mhm. Um, so the enterprise version is based on the open source, and it's basically a fork of the open source version. And every time that we release another enterprise release, we fork probably the latest open source release, and we carry on all of the non-open source components, and they're not much. It's primarily security features and a couple of performance or TCO based features. But
Hmm.
just like that, it's almost the entire code base is open source. Um, Naming is um, we handle naming for open source, and the naming for enterprise is more to is just functional. So we just base it on the year of the release. So enterprise users will have an easy time to figure out the lifetime of the enterprise release.
Okay, okay, I see. I'm guessing that you also have like specific support periods for the enterprise version. So, for example, for the current one, which I think is 2022.2, what's the standard period of support?
So it's usually something like 2.5 years of support.
Hmm.
So it's beyond the year of the release. There are additional 2 years of support. So on average, 2.5 years.
Okay, okay, I see. So when what's in your agenda? When are the next releases, both for the open source and for the enterprise version coming up?
Mhm. 5.2 release will going to have a consistent transactional schema operation based on Raft. So that's a big improvement because originally in Cassandra there were no consistent schema operations, and it was a big gap. For those who follow our project, we did in the next release after this 5.3, we'll also have a transactional topology changes. For those who follow us, I can give an example. we passed the Jepsen reliability and consistency test 2 years ago. I think it was 2020 or so. Now we pass it with flying colors, but or maybe or with an interesting color that Kyle is writing. So it's not that flying colors to be exact. And if you're familiar with his style. Um,
Yes, he's very characteristic figure in this space.
yeah. Now, when passing it, we had to make uh, we have to make the limitation that you can pass it as long as you don't change the topology and you don't change the schema. So that's and these were the consideration. But basically, you're allowed to do one topology change at a time. So you can't add two nodes at once, or you can add and remove node altogether at the same step. So that was a major limitation. Also, schema changes. It's something that more sophisticated organizations may want to do programmatically and not just at rare occasions where you change a table. So Raft allowed us now to serialize all of these changes in 5.2 the schema, and in 5.3 afterwards we have it working on the master branch, not yet released, the topology changes. So we'll be very agile and we'll be able to pass Jepsen together with many topology and schema changes. And this is just a preparation towards bigger changes, which will change the way we treat, we shard data. Today, the sharding is automatic, but is usually it's done on the timing that you add a node to the cluster. This is where the time that we allocate key ranges to that node. And we want to make it way more dynamic, so we'll be able to load balance. Even if the hardware doesn't change, we may want to load balance things across shards and work with smaller units, which we call tablets. And also, if you add hardware, you'll be able to separate the process of adding hardware and the process of load balancing hardware. And practically, you'll be able to use that new hardware that you added to the cluster way faster, because tablets are units of work of the form of 10 gigabytes. So you can quickly send another 10 gigabytes and immediately serve data from a new node for that range, as opposed to what we have today, where every node, let's say if you have 10 terabytes, you need to complete to transfer 10 terabytes and only afterwards start serving from that new node. So this is a big change, and we'll probably deliver it towards the end of the year. Could be beginning of next year too, because we're trying to do lots of tests before we release something to general availability.
All right. Um, okay, so I think we're close to wrapping up, and let's. I want to pick up on something you mentioned earlier about, well, people who follow the project. I noticed there's also something new, something else new, which is, well, maybe otherwise minor, but somehow connected to what you said. I saw you have a new community forum, and so I was wondering that if that means anything with respect to your contributor base, because I think based on, well, previous conversations, that it used to be that your contributors were mainly coming from ScyllaDB employees, and for a number of reasons, because uh, it's uh, it's a complicated project. It's in C++ and using your specific C star library, and which not many people are comfortable in using. But have you seen that maybe change? So are there more contributors as of late, and this is maybe the reason why you have a new forum to serve them?
So the contribution for the core database remains limited because it's quite complicated. But we do have more contributions to the C star, which is complicated, but people pick up C star and use it for their own usage, and they build other things with it. And also we get lots of contribution to peripherals, whether it can be drivers like Go, and sometimes Go tool sets on top of the Go driver. One of them was presented by one of the open source users at the summit. Can get contribution to the drivers, or sometimes to graph open source graph tools that use Scylla under the hood. Both Quinn was at the summit, and just recently, Janus Graph added an official support, backend support for Scylla. So there's a variety of options, and we added the community forum in order to have another place for people to ask questions that can assist other community members, because we have a pretty vibrant Slack community with more than 5,000 people there. But usually Slack is kind of temporal. You ask something and it vanishes. And the community forum stays, and people can first search the forum before they ask a question. So it's a longer term type of resource.
Indeed, yeah. You just touched on a chronic pain point with Slack. Actually, yeah. I mean, it's pretty good for ephemeral things, but if you want to refer to some conversation or some answer that took place a while ago, it's pretty hard to do that. So yeah, I understand why you introduced the community forum. All right, great. I think we've reached the end more or less. So at least I covered everything that I had in my list. I don't know if there's anything else that we didn't touch upon that you'd like to mention.
No, George, I think that we covered a lot, and I'm impressed with the depth that you have, and how you track the project. And I hope that people enjoy it, and will be excited to follow the project, contribute, or join the P99 conference as well.
I hope you enjoyed the podcast. If you like my work, you can follow Link Data Orchestration on Twitter, LinkedIn, and Facebook.